What's up everyone? Today we're diving into Dolph on echoCTF. This box had me chasing shadows for a few days. I was totally convinced the path was LFI to RC, but nope. Classic rabbit hole. After a lot of digging and a bit of stubbornness, I finally cracked it. Turns out the real trick was analyzing a binary hosted on the web server and using a sleek combo of LD preload and an X forwarded for header bypass to pop a shell. It was super fun, super sneaky, and I definitely picked up some cool new tricks. So let's break it down together. I've already started the machine. There is one service. I'm connected with the VPN. Let's check our connection. All seems to work fine. Let's create a directory and call it Dolph. Create another directory, call it nmap, and one for fuzzing. Let's do VV for double verbose, all ports, the IP, T4 to make it go faster, and app in all formats, and save all the output of the nmap in all ports. Right off the bat we see port 80, it's open, so we don't have to scan to find more ports, as we know there is just one service. So let's run some scripts on that port, -p to specify the port, -a for all scripts. Let's visit the web server and see what we get. Data downloader service. Okay. The map is finished. So let's open our nodes and save that. Let's call it Dolph. Create a subnode, call it nmap. Put that there. So we can see nginx. Whoops. And we can use get and head as HTTP methods. Can go ahead and create another subnode, HTTP 80. Put that there as well. Okay. Let's view the source code. Save that as well. Documents, Dolph. Create a new directory, call it CT, the name is notes. Cool. Okay, from the source code we can see it's running on PHP. Let's just put PHP. As you can see here, we find a hidden directory. It's called admin, and the flag, of course. Let's just put that here. Okay. Before we move on, let's start directory brute forcing to have something running while we manually test the web. Let's move into fuzz. root directory. Let me explain this real quick. So we're using GoBuster. It's a tool like Dirtbuster, just the tool of my choice. We're using the directory mode. We're specifying our target, the URL, and I'm using the checklist discovery web content raft small files. Let's make that rsw and use the raft small words instead. And let that finish. So data downloader service dot in file name is not allowed. Suppose here only data, no scripts. Okay. Okay. So first of all, let's try and access. Let's see if we can reach ourselves. Let's make a new directory, go into that and just create a test file, test. Okay. Okay, 11.150 test, or like this, and the file name here. Where did we open the server? I know. I had Mythic running. Just a second. Okay. Let's try that again. So it seems that we are able to reach our web server, and it seems that the file is uploaded successfully. Let's check that. Okay. Get this back. Okay. Let's try and upload a script now. So let's move test. Let's remove test and let's create a test.php. Just a simple PHP script. Please sub. Okay. Test.php. Not allowed. Okay, let's try. Maybe if we put the file here and just call it test. Download this again. Here we go. So it seems that the file is not being executed, but the web server is turning the context of the file we upload into a string. Also, it seems that the web server, even though that's a PHP file, it does not recognize it as PHP. It downloads the file rather than executing it. So let's see if that's the case for sure. Let's try changing our script to a web shell, and maybe we're lucky. Request cd get back. Alright, we do cmd calls id. Now it seems that is not executing it. So that won't be the case. Let's clean this. Okay. The next thing I thought when I saw this is maybe this is doing a curl, and we can append and inject a command ourselves and totally ignore the file name. So we can go ahead and do like, let's put a URL there and then do semicolon and then do ID. Test this. And in order to do that more efficiently, we can send that to burp and then fuzz this character right here. My thinking is that if we do curl HTTP ourselves and then do semicolon ID, you see that the curl executed, but the ID command executed as well. So this is what it's in my mind right now. Let's go ahead and check our philosophy. Okay, let's minimize everything. So we can set that to the intruder, and let's find the special character. So we want this. I think is this right here, right? Yeah. Let's make this. I think there is a list of sec lists with special characters. Let's see. Yeah, there it is. I think this is the one. Yeah, we can try this. Fuzz URL encoded. Yep. The thing now is that we are overwriting test, so this is not helpful. Let's do it manually. So let's check this first. Go to test. Can't see 0 bytes, nothing came back. Can try and test. Nothing came back. Can also try or. Zero bytes. Nope. Let's tried or, we tried and what else? So we try quote. See how this goes. Nope, that's not the case. Yeah, so it's treating it as a string, as you can see, because we're getting the get request, but then it appends the ID next to it, so it's not interpreting it as a command. Okay, let's see what's going on with our fuzzing. We do have uploads. We know what uploads is, where we find the files that we upload, and we have admin. Let's go ahead and check for files as well. Let's do files, index.php. Okay, let that run. Minimize this. So we checked, we know that we can reach ourselves, but we cannot execute scripts until now. We can try bypassing the dot. That's one thing we can do. Let's write some notes though. So we can reach ourselves, our server with the URL input. We try to the server converts the context of the files we upload to string. So our scripts do not execute. What else do we know? We also try command and injection using the URL using and or what else can we try? Can try bypassing the dot. Let's try that. So let's take test the PHP and test the PHP. So download. Let's find the last request. There it is. And we can go ahead and URL encode it so we get not allowed. So we can right click, convert section, encode, send, not allowed. Let's double encode it. Send, not allowed. Okay, let's maybe Unicode. Send, not allowed. Do we get the requests? We don't. Okay. Did I write the RIP wrong? No, it's correct. Oh wait, this is what we have to modify. So let's go again. Convert. Let's see. Not allowed. Let's try double encode. It passed. However, it didn't pass as we want, but maybe it worked. Let's check that. CMD calls ID not found. Yeah, it changes to dot, so this didn't work. Let's try making it Unicode. What about this? It seems that it did upload. However, you cannot find the file, it seems. Okay. So this didn't work. We can try the null terminator. if we put how do I use that? I forgot. Let's disable burp, refresh this, null byte action, there it is. So an attacker wants to retrieve a file, etc. password button extension is appended automatically, such as this. Yeah, but in our case there is no extension appending. An attacker wants to upload malicious.php, but the only extension allowed is .pdf, so it does this. We can try double extension, so we can go ahead and do .php.pdf, but I think because it has dots it will still not pass. Yep. Okay, let's try the null injection just for the sake of it. Not allowed. Okay. Before we move on, let's check our fuzzer. We did find index.php. Okay. What else can we try here? So let me minimize this. Cool. So we can try and reach the server itself, like SSRF, like 127.0.0.1. Also, while we check this, as we saw before, there is an admin directory, so let's fuzz that. Let's do admin. Let's start with files this time. Admin/go, and there is another index.php in the admin. Okay, so we can go ahead and try to grab index.php. Let's see if we can access the local server from here. Let's call that test again. It seems we can. Let's see. Test. This is okay. We retrieved something back. This is 4. And there we go. Now we have the source code, it seems. And we got a flag as well. However, there is nothing here that we don't know. Okay, so we can reach inside, and as we see, we saw from our fuzzer, there is an index.php. Now let's move into fuzzing words. rsw words. Nice, there's a login. This is spicy. Okay, so let's check what is in admin. 127.0.1. Let's do admin index.php. Test. We got something back again. Let's check what's that. Hey, we get another flag. Just like this. Wait. What is in admin? Let's go and check ourselves. Admin. Whoa. Okay, so mistakenly we bypassed this this restriction because we tried to Here, as you can see, when we reach admin index, we got a flag. However, when we try to go through the browser, it says that this is restricted. So there is a restriction here that this page can be accessed only by coming from locally, it seems 127.0.0.1. However, because we've went through the uploader, so the server itself tried to access that path, we got back a flag. Okay. Also, we do have admin/login. Let's go and try to access this. So we downloaded something. It seems that this is an executable. Okay, let's analyze it. We don't need the server anymore. Let's exit this. Let's create a file and call it files. A folder, sorry, directory, let's say. Files, move into files and copy right here. Let's use strings first on it. Maybe there is something hidden. There is a flag, we found that already. It seems that the usage is that we use the binary and then an IP, it seems. SO.2. So SO is a shared object, as I remember correctly. And that is the error as well, only is allowed. So it seems that this binary gets executed when we try to access admin, because this is the error that is showing here as well. And when we access that through the URL parameter, we got the flag, which seems is the same flag, B848, and this is B848. So let's try and execute that login. So let's say we put the IP of the target server. Only 127.0.0.1 is allowed. This is the error we're getting right now. And when we put this, we get the flag. Okay. Let's see. We can go ahead and try some sort of can try using PHP wrappers. Let's see. So yeah, I want to explain what PHP wrappers are. Whenever I'm against yeah, this must be a good one. That's all of them. So whenever I'm against a web server that uses PHP, PHP wrappers are very helpful, and a lot of attackers are using them. So I'll try to explain what they are. And let me see. Files on the server. So let's think of wrappers like special tunnels that help PHP to do cool tricks with files. Like normally PHP opens files from your computer, but with wrappers you can do more like look at the file and change how it's read, get raw data directly, even load stuff from strange places. So most of the times hackers use it to they use these tunnels, let's say, to sneak around filters like reading secret files or adding their own code without permission. However, there are some requirements that have to be met before being able to use all of these wrappers. I remember there is an article talking about this, I think. So yeah, so the filter wrapper does not require so there is some prerequisites, attributes, it's a better word. The attribute allow URL include must be set in order to use the data column // However, we have to make sure that we do have an LFI, and it seems that we do not till now. We can go ahead and try that. So let's try directory traversal, like rather than putting a URL, let's try access etc password D, and let's call this password D, for example. It seems that it uploaded. Let's go to uploads password D. Oh, and we get a file back, 1 kilobyte. And yep, we do have directory. Is it directory traversal? I don't know if that's the name of this finding, but it seems like. So there is another flag. It seems that we can pull files through that. Let's see how we can abuse this. Let's try and grab the admin index PHP, because we didn't figure out what's in there. Also, let's grab both index PHP files, and from root and from admin. So most probably they are in var html index.php. This is the default path of most web servers running on Ubuntu. So let's root index. Let's download this and see what we have. Root index, and we actually get something back. Let's check that out. Cool. So as we can see, we get more content back. Now it's and we get a flag as well. So let's save this in a different, because this is important. Let's put that in our documents, Dolph files. Call this root index.php. So now we get the colors as well. So it seems that this is why we can get files, and we are allowed to do directory traversal and lick files. Local file read, I would say it's the name. But as you can see, .upload, it's hard coded. And here it checks that if the name has a dot, then equals to false, and we get the not allowed back. So we can abuse this and try some of the PHP filters we mentioned earlier. But first of all, let's pull the, let's see, pull the index PHP of the admin. So let's go var, just put admin here, and let's call this admin index. Okay, let's see what we got. Nice, this is juicy. Let's save that. Documents, Dolph, files, let's append.php. That's another flag. And right off the bat, I see something interesting here that maybe we can abuse if we find a way to do that. So this command here is execute system commands, or it executes something, let's say. Let's understand what's going on here. So it seems that the code, it tries to figure out our real IP address by looking at several headers to guess our IP. So it checks for headers like x forwarded 4, x cluster client IP. You get the point. And the first one that finds that has a value, let's say, it stores it as an environment variable right here inside the variable IP called IP. Then it checks if our IP has a code, then it's false and we get echo goodbye. If it doesn't have a code, it continues to execute login, which is the binary that we previously downloaded, and then appends our IP in quotes, and we get the output of the login. So what I see here is that maybe we are able to control the IP that goes here. However, we have to append one of these headers, and so we can control this variable. So let's go ahead and try this, but first of all, let's check one of the headers, like this one. And I'm choosing this one specifically because it's an interesting one. There it is. So this is the syntax. Just put that in our request, x forwarded 4 client proxy. So in a few words, what this does and how I understand it, what that header is doing, is that let's say you are at a school and your friend passes your homework to the teacher for you, right? And the teacher asks, who did this? And your friend says, this is from Alex. Let's say this is exactly what X forwarded 4 does. It's a message in a web traffic that says this request really came from this person IP. So maybe we can use this to trick the target web server, thinking that we are coming from locally 127.0.0.1, right? Also, the other interesting thing about this header is that we can append a lot of values just by putting comma, right? So let's go ahead and check our theory. Let's go back here and let's first of all enable burp and go to admin, and we get only 127.0.0.1 is allowed. Let's find the request. There it is. Send it to burp, and let's put the header. So it's x dash forwarded dash 4 column 127.1 send, and we get the flag. So we actually, yes, we did get the flag, but what's happening behind is that as soon as the binary login so that x forwarded 4 header exists and the value is 127.0.0.1, then it gives us a flag. If we change this to something else, let's say our IP, right, we're gonna get only 127.0.0.1 is allowed, right? However, now what? I mean, okay, we bypass the restriction by appending this header, and we get the flap. However, I really don't. Here is where I was stuck for 3 days. I didn't know how to continue, so I said to myself, this is a CTF, right? And there is a reason why this was hidden, right? Like the admin. So I was like, something has to do something with slash admin, and in the slash admin we got the binary. So I started playing around with the binary, and I find some ways to analyze the binary further. So I did an imaginary case where, let's say I was on the server, right, and I was about to abuse this binary, and I had control over the get IP, which we do have, right? Then I went back and did this. So this is a binary. We do have the 127.0.0.1. So if I'm able to append something like this and do a command injection again and do ID, you see the binary is getting executed, but also our command is being executed as well at the same time. We can also try this, which is and then what we did before, but nothing happened. So this should work, right? However, how am I gonna append this here? So what I tried at first is just doing comma and append the command here. I was like, maybe I get an execution, right? When I did this, however, it treats it as now we are no longer 127.0.0.1, but we are all these with the semicolon and ID. Then I went back to the X forwarded web docs, and I was like, I can I can put extra values by adding comma. However, that's not the case. We can go ahead and try it. Let's say we put the comma there. Now we do get the flag back, but we cannot see, there is no indication that our command is being executed. So instead I was like, maybe it's a blind one, you know, maybe it's being executed but I cannot see it. So what I did after is I tried, you know, making a curl command to myself. Maybe if it's blind and I can't see it, maybe the command reaches me. So let's see, let's open a Python server and see if we get the server to reach us. So I did this and nothing happens here. So I said, well, maybe the port 80 is blocked, right? So let's try pinging ourselves. Ping C to 150 and open a sudo tcp dump. There we go. Let's try that. Nothing happened. So okay, I said maybe I should inject this without the 127.0.0.1. Maybe this gets executed, right? So I tried this. Nothing happened. Then I went back and tried the curl again, and I hit a wall, right? So I went back, I did I see the bigger picture, and as I said before, this is a CTF, right? I mean, it must be a reason why sorry, this is hidden right here. So I went ahead and examined the binary more. So instead of running only strings, I went ahead and tried other tools, and the one that helped me is the ltrace. Let me find the tool. This is it. So there is a lot of so it traces library calls of a given program, right? So imagine a magic notebook, okay, that writes down everything your robot says and hears, for example. So every time the robot talks to someone, boom, it's in the notebook. So this is what ltrace does. It watches the program and writes down what it says to the libraries, the helpers it uses to do things like run commands, compare passwords, open files. So like malicious users or hackers, let's say, use it to spy on what the program is really doing, right? So if it secretly checks password or runs something dangerous, ltrace will tell you. Also, there is another command, strace, right? This is doing the same thing as ltrace, but rather than checking for libraries, it's checking for system commands. This is how I understand it, okay? So let's see, maybe there's a description here. This is long. There is not. So let's run ltrace on login, and we don't see anything here. Let's append the okay. Now I think there is -I. So we see strcmp, it prints this. What happens if we put something that RIP to make it fall? 11.150. So we get back this. So now let's try strace. Let's do -h just for a second. Central point at time of library call. Here we specify the library. So we can append this. Let's do S. We don't get anything. Let's do 127.0.0.1. And let's try strace as well and see what happens. Much more output, right? So I started trying to read this, and I saw here that exec, this is executing something, right? And then I saw this, and what this tells me, I don't know if you guys ever played with DLL hijacking or DLL injection. So it's about the same thing. So when an executable runs in Windows, it searches for some specific DLLs, and if the DLL is not there and you have access to the path that is looking for the DLL, you can create your own DLL and then hijack the process, let's say. So it's the same thing here in Linux. In Linux, however, there's not called DLLs, but they're called shared objects. And in my understanding, in Linux you can preload these objects before a binary runs. So again, how I understand it and how I can explain it is like, imagine a toy robot that normally grabs blocks and puts them in a box, right? But before it starts, you secretly give it a new instruction, like, let's say, before doing anything, play my sound file instead. So this is what LD preload does. It tells a program, hey, use my version of this action, like grab it or printing before anything else, right? So again, hackers use it in a malicious way. They make a fake piece that runs a secret command, like open a shell, for example, and trick the program into using it. So now that we know that this binary allows preloading, we can try preloading our malicious shared object, and then maybe execute our commands instead, right? So let's see how we can do that. First of all, I found a very nice article, of course, for hack tricks. So let's see, LD, there it is. Let's disable burp for now and do a refresh. You can go ahead and read this. It's an amazing article. I just want to get to the juicy part and show you how it works. So in this scenario here, the preload exploitation is being used to get higher privileges, like from low user to sudo. And here it shows us how to generate a C program file inside temp directory, right? And this is the malicious C file that will then be compiled into a shared object. However, as you can see here, because they're trying to get more privileges from a low user to root, let's say, they're setting the GID and UID to 0, which this is what root has, as I remember, if I'm not mistaken, and then they execute binsh. So what happens here is that they compile it as a shared object, right? And then they do sudo ld preload the malicious shared object, and then find, which is the command they are that allows preloading, let's say, and then they get root. So in our case, if we want this to work, first of all we have to remove these two, because we don't know if the login binary is used by root, and we don't want to get root immediately. So for just for now, we want to get initial access on the box. So let's go ahead and try this out. So let me copy this example right here and go back to my terminal, clean this and go back to nano, let's do shell.c. So first of all, we want to remove this. Also, we don't want to spawn a shell, but instead we want to make sure that this works. So what we're gonna do, we're just gonna do curl and try to upload a malicious file on the server if that works, right? So let's call it rev, right? And I'll put this into temp, because the reason I'm choosing temp is because it's word writable. Everybody can write on temp most of the times. And let's say this. Then we're gonna go ahead and use the command they've used for compiling a C code to a shared object. Okay, now we do have shell so, and then we have to do this. So we have to specify the by the way, ld underscore preload is a global variable, if I'm not mistaken. So now we want to call the preload on our login login binary. And in order to make sure that this works, we can try it first locally before we attempt to try it on the target. So what we can do is let's move the login here, right? And let's do ld preload equals shell.so, and then run login. Also, to make sure that this works, let's split this and open a web server and see what happens. So as you can see, it ran first our curl and then it attempted to run the login, right? So we are sure that our malicious shared object is indeed working. Okay, so let's see, how did we call the malicious file we want to upload? Shall C rev. So let's go ahead and create let's call this rev. So I'm using MS Venom, Linux x64, shell reverse TCP. This is my IP, and the port I want to I'm gonna be listening on, so I get the reverse shell part. So let's create this. And let's open the server, so we'll wait for connections. So the thing, when I saw this, and I understand that, okay, that might be the way. The only question I had in mind is that, as you can see here, is using shell.so. However, we cannot upload files with a dot, as we saw before. There is a restriction on the upload. However, it seems that even though .so is not specified, Linux still identifies that file as a shared object, so that won't be a problem. Also, how do you think we can upload a file and then, you know, we have to specify where this file is? So what we can do, it's go here, let's see, go back to the downloader service, call shell.so, and let's call this shell. Okay, so it got our file and now it's saved as shell. Let's make sure that this is the case by trying to download it and go to, let's close this. This is admin. Let's open another pane right here. P10030. Okay, let's check if this is a binary. That's perfect. So it seems that it's been uploaded successfully. And let's see how we can execute this. So let's head back and understand the code once more. So what we control right here is the get IP, right? So it checks for the header, saves the value of the header in IP, then creates an environment variable with our IP, and then it uses that IP here. So what we can do is actually put ld underscore preload equals var html and shell. Also, this is not enough, as we have to when we preload our malicious shared object, we have to call the login. We have to call the binary. So let's see what's gonna happen. What is supposed to happen is that it will upload rev in temp as we specified. So I click send and nothing happens. Great. Let's see why. LD preload, is that correct? LD preload load. I have to put uploads shell. So now let's check. and we get the reverse shell. I mean, we managed to execute. We have now execution on the server through our shared object. So what we can do now is go ahead and change this and make our reverse shell executable by calling chmod +x, recompile it, then re-upload it and execute this again. And now we can go back, modify it once more, so we execute now the reverse shell, recompile it, listen on 443, and let's see, fingers crossed. Nothing happened. Why? I didn't upload it. Let's try and re-upload it. Back here, upload that. Let's see, back here, and it hangs. It seems that we do have a reverse shell. Yay. Okay, let's upgrade our shell. We can use Python to do that, of course. I've shown this in the previous videos, but I'll show that again. First of all, we'll have to know if Python 3 exists on the server. It seems that it does. And then we can say Python 3-c import pty.spawn, which will spawn a Python inside Python a bash. Then we can Control Z, sct-row-echo -echo and foreground. Also we can export term equals xterm, and I'm not typing, so term equals xterm. And now we have a full interactive shell. Also the last thing we can do is this, rows 30, columns 133, so stty. Okay, so first things, let's see if we have any dangerous group. We don't. Maybe we have we are in the sudoers group. It seems that we are, but we need a password and we don't have a password yet. So let's go to temp and upload link piece. Let's locate link piece. Where are you? There it is. Okay, let's upload link piece. So let's upload it to temp. Great, let's make it an executable. And let's run it. Let's see what we get. Okay. And that's an easy one. So it seems that we do have write access to etc password D. This means that we can create our own user with our password, and we can specify that that user it's a root. We can go ahead and do that. So first of all, we have to create a password. We can do OpenSSL password D and the password we want to specify, so we get the encrypted version of it, and this is the encrypted version. Then we can go ahead and do, let's cut et password D, and what we can do is just replace X with a new password. So let me copy this. Can do echo this, let's call this root win root 2, let's say, and put that password there like this, and append this to etc password D. I did a mistake. etc password D. Okay, and then switch to that user and specify root as a password, and we are root. Let's go to root, and there's a flag. I hope you guys enjoyed this. I hope you learned some stuff, because from this box I learned a lot, even though I had nightmares about it. And see you guys on the next one. Bye.